Hi friends, in today's video, I will be teaching you how to assign the RNS configuration. Now the RNS configuration is assigned to a carbon which is connected to 4 different atoms. As you can see in this example, a carbon which is connected to a carbon, a chlorine, a hydrogen and a fluorine. You assign the priorities based on the atomic masses. That's the first rule. So the atomic mass of carbon is 12, right? The atomic mass of chlorine is 35. And the atomic mass of hydrogen is 1 and fluorine is 19. The second step is to trace a circle. So you start with a group of the highest priority, which is chlorine. So chlorine will have the highest priority, so it will be group number 1. Then you go to the second which will have the second highest atomic mass. So fluorine has the second highest atomic mass, so it will have priority number 2. And then carbon, which will have priority number 3. Then here, this one will have priority number 4, hydrogen, since it has an atomic mass of 1. Now you have to trace a circle from the group of highest priority to the group of the third highest priority. Usually, we do not consider the fourth one. If we pass it through the fourth highest priority, it doesn't make a difference. So we start from chlorine, we go all the way to the second highest priority, and then go to the group of the third highest priority. Trace a circle like that and draw this arrow. Now you have to check whether this is in the anti-clockwise or the clockwise direction. As you can see, this is in the anti-clockwise direction, so it will be an S configuration, right? And now, how do you remember this for your exams and all? You might get confused between the clockwise and anti-clockwise direction. So here's a simple trick. How do you draw an S? An S is drawn in this way, right? You started like this. So what is this? This is going in the anti-clockwise direction. So it's S. How do you draw an R? You draw an R by drawing a line and then drawing a circle like this. And what is this? In which direction? It's in the clockwise direction. So if you get a circle like this, then it's the R configuration. Now let's do the second example. The atomic mass of chlorine is 35. Of hydrogen it's 1, oxygen it is 16, and carbon it is 12. So let's draw the circle again. So we'll start with chlorine, which is first highest priority, then go to oxygen second, then carbon third. So we trace the circle like this. Again, we are getting the anti-clockwise direction, which is the S configuration. Alright. Now let's go to this example. This is a little bit different from these other two examples that we solved. Now your carbon is connected to a carbon, a hydrogen, a carbon and an iodine. It's not connected to 4 different atoms. Now what do we do in this case? We check the atoms that are connected to this carbon. Like here there's a hydrogen and an oxygen. This carbon is connected to a hydrogen and hydrogen. So let's assign the priorities. I'll just use a different color. The first priority will go to iodine because it has the highest atomic mass. The second priority, in order to discuss the second priority, first we'll draw the atoms that are connected to this carbon. So there's an oxygen, a hydrogen and a hydrogen. And now the atoms that are connected to this carbon, a hydrogen and a hydrogen. Now, as you can see that the oxygen has a high atomic mass. So this will get the first priority. This group will get the first priority. And hence this will be a second highest priority. This will be a third highest priority and this fourth. Trace a circle from first to third. Starting from here, go all the way to third. What is this now? This is in the S direction because this is in the anti-clockwise direction, right? Like this. So it's the S configuration. But since the group of the lowest priority is on the horizontal line, it's on this horizontal line, therefore we reverse the configuration according to this rule. So it changes from S and becomes an R configuration. So this molecule will have an R configuration. Let's go to this example. There's a carbon, nitrogen and oxygen. So nitrogen has an atomic mass of 14, carbon 12. So now what do? This one will have the first highest priority. Carbon is connected to an oxygen and a... Okay, so whenever there is a double bond, you consider it as 2 oxygens. Oxygen. There's another oxygen here, so another oxygen. Now this carbon is connected to hydrogen, a hydrogen, and a hydrogen. So obviously this will get the first priority. So it will be here. Second highest, third highest, and the fourth highest priority. So now we trace the circle from first to third, going all the way like this. So what is this? In the S direction again, but the group of the least priority is on the horizontal line. So we change it and it becomes the R configuration. I hope you have understood this. Let us solve some more examples. Here we have some more examples to solve. Let's start with the first one. Carbon, CH3, an OH and an H. This one has an atomic mass of 16, so it will be the first. Carbon 12, so it will be, since it's connected to oxygen, this is a structure like this, right? C double bond OH. So it will be an oxygen, and a hydrogen. And the down one will be a hydrogen, and a hydrogen. So this will get the second priority, this will get the third priority, and this will get the fourth priority. So you draw from first all the way till third. So this is in the R direction, but a group of least priorities on the horizontal line. So it changes from R and becomes S. Alright. Now let's take another color. This one. So Br has the highest atomic mass first. Now here. Okay, so here a carbon is connected to a carbon, a hydrogen, and a hydrogen. Right? Because there's one carbon here, one hydrogen, and two hydrogens. And this carbon is connected to a hydrogen, and a hydrogen. So the atomic mass of carbon is more than this hydrogen. Therefore, this will get the next priority. So this will be second, and this will be third, and that obviously fourth. So you trace the circle from 1, go all the way to third. So what is this? This is the S configuration. And it will stay the S configuration. It will remain as the S configuration, because the group of the least priority is on the vertical line. Now we go to this example. Now CH3, a COH, a deuterium, and a hydrogen. This will get the first priority as we discussed earlier. Second. Now deuterium has an atomic mass of equal to 2. So it will get the third highest priority. And this fourth. So we trace a circle from 1, we go to 2, then we go to 3. So this is in the clockwise direction. So it is an R configuration. But the group of least priority is on the horizontal line, so it changes to the S configuration. So this is the S configuration. Let's take this one now. We have an NH2, a hydrogen, a CH3, and a phenyl ring. Now, how do you draw a phenyl ring? Phenyl ring is drawn like this. Alright, so this carbon is double bonded to one carbon and single bonded to another carbon. So you have to take that into consideration. Nitrogen will obviously have the first highest atomic mass, 14. So you get the first priority here. Then there's a confusion between this carbon and the phenyl group. This carbon is connected to a hydrogen, and a hydrogen. What about the phenyl ring? The phenyl ring, the carbon which is here, you can see, is connected to a carbon, and a carbon. Since I told you a double bond is considered as two atoms. So the first atom over here is carbon and this first atom here is hydrogen. So this will get the next priority. So second, this will get third, and this will get the fourth priority. So you trace a circle from 1, cross the fourth, go to the second, and go to the third. So it's in the clockwise direction. Therefore it's an R configuration, and it stays as the R configuration. Now you can complete the remaining as a homework and check your answers with this.